pre-work, that material that goes with this, that would be day 23 pre-work. Now where did I just set that pen? Right here. So day 24 activity goes with day 23 pre-work, because we had to shift a bit, in case you're interested there. Okay, whoops. Oh, clearly it doesn't like that corner. Okay, all right. So rational functions. Basically, when we think, tell me some things you think about rational functions. If you're going to graph a rational function, what do you need?
Asymptotes.
Asymptotes. Two kinds. What are these called?
Horizontal.
What's this called?
Slant.
Oh, sorry. A hole. Oh, or slant or oblique asymptotes. All right. And then we need some points, right? What kind of points do we always like to find?
Intercepts.
Intercepts, X and Y intercepts, yeah, and if there's a hole, etc. Okay, so we have talked about the basics for finding the asymptotes. We haven't done any of the oblique or slant asymptotes, so let's do that, and we'll even look at another one that has a hole in the graph, okay? Which is called a removable discontinuity. Here's the steps that we follow. I think you have this in your handout. So where are we? We're here. So do you long division? You did long division in your pre-work, right? How many of you remembered long division when you got to the pre-work? Did you go, oh, I kind of remember that? Some? Mm-hmm. Did it come back to you? Did you feel better after you did practice, saw the video? Kind of? I used to absolutely hate teaching long division. I don't know why, but now it doesn't bother me. It's weird. I don't know, life changes. Okay, so if you think about long division of numbers, it's really the same process. I mean, I don't know about you, but to me, long division of numbers is painful. I have to be like, oh my God, do I really have to do it by hand? And we can probably get away from it, right? But it's really that process. So this is the process. The thing that, unless you watched both videos in the pre-work, you probably did not see an example of this step. Did anybody watch both videos, the guy and then the girl, for the long division? Oh, cool, nice. Yeah, the second one, Nancy Pye, with the cool clear board that I want.
Does she write backwards on the board, or is that camera magic?
I think it's camera magic.
Okay.
So you can like kind of like do like reflecting,
Yeah.
like photo editing and stuff. And
Yeah,
Yeah,
a lot of people do that. There's a lot
Like,
of.
how smart is she? She's writing
Yeah.
backwards.
She went to MIT.
Yeah, I know, but she's just rubbing it in.
Yeah, she's good. I like her. I thought I talked slow. She talked slow. I speed her up even.
Speed up all the videos.
You probably, if you listen to any of my videos, you'd speed me up too. Trust me. Okay. Well, anyway, so that's the step right there that you maybe didn't see. So we'll do one of those together, if that's okay with you, and then I'll let you do one of the regular ones. Oh, FYI, I know there are some times when you can do the division with synthetic division. We don't do synthetic division anymore after college algebra. Okay, you need to use long division, and it's just because you need long division for other things in calculus. So make sure that you're practicing long division, even if you can do synthetic division for some of them, because some you can, but you can't always. So those days are gone. Those are nice for finding zeros, but now you're going to find zeros with like Desmos or something. Really? Okay. All right. Here we go. So let's do it. Is this attached? Tell me it's not attached. Oh, it's not. Yay. Okay. All right. So here we are. Okay, so I want to take this polynomial on the top and divide by this polynomial on the bottom. Well, technically, let's start from scratch for a second. So if I look at this and I said, okay, I want to know if this rational function has a horizontal or a slant or oblique asymptote. We compare the degrees of the numerator and denominator. Technically, we should see if there's any common factors, but the top is not factorable, so I know the bottom is, but there are none, so we're kind of skipping over that step, but there aren't any common factors, or we would look at that. So the top is bigger than the bottom, right? So that means top greater than the bottom. So that tells me there is no horizontal asymptote. Okay, none. That means far to the end, the graph does not flatten out and approach a horizontal line. Okay, so it's greater by only 1, right? 3 is greater than 2 by 1. If it was 5/2, there wouldn't be a slant or oblique asymptote either. But it's only greater by 1, so we know that there is a slant asymptote. Technically, I believe an oblique asymptote is an asymptote that is not horizontal. And it doesn't have to be a slant asymptote. You can have an oblique asymptote that's like a parabola or something, okay? But the only oblique asymptotes we look at are slant lines. Okay, slant lines with a slope. Okay, all right, so there's one. So what do? We have to divide. So when we do our long division, here's the thing. You have to have your polynomial in descending order, and every power has to be represented. So notice how I have 2x cubed. My next one is x squared. So my next power should be x to the first. Do we have an x to the first power up there? No. So we have to add that with a placeholder. So 0x is like no x term. You have to have every power represented in descending order. And you have to have a constant. So if there's no constant, you would add a 0, but there is a constant. Because that would be a power of 0 on your x. That's the degree. Okay? Now, your divisor also has to be in descending order and every power represented. There's special cases where you can get away with it. Like if all the powers in the top and all the powers in the bottom are only even, then we could get away with it. Or if they're only odd, it would be okay. But if there's a mixture, we have to put it in both. So this is going to be x squared. Notice how I don't have an x term. And then minus 4. So it's both of them. The divisor, we typically don't have to do that, or it doesn't happen as often. Okay, so then what do? We divide. And when we say divide, we divide the first term. And I don't care if goes into works for you, but goes into seems weird to me with variables. So you're dividing. 2x cubed divided by x squared. What do you get? 2x. Okay? It really doesn't matter where you put it in the top. Sometimes they say it has to go above its like term, like some books will tell you here, some books put it right here. It makes no difference. It's not like numbers or decimals. Okay? But anyway, I'll put it above the like term. Makes no difference. Okay, then what do? After we divide, so what's the process? It is divide, and then the next step is multiply, and then it's bring down. Oh no, I skipped one. Divide, multiply, third one is subtract, which can be add the opposite, depending upon what you like. I'll give you a little warning on that add the opposite. And then the last one is bring down, the next term. So it's exactly like you do with numbers. So if you needed to practice it with numbers as a review. Okay, so now we're going to multiply. So we're going to take this term times all 3 of those. And then they should line right up below their like term. So 2x times x squared, 2x cubed. 2x times 0x is 0x squared. 2x times negative 4 is negative 8x. Okay? Then we're going to subtract. Now, if you watched, Mario's video, he did the subtract or add the opposite, which I used to always do, and I feel like sometimes that messed people up, but it doesn't matter to me. But here's my recommendation. If you change the signs, I recommend you use a different color. Because if you go back to check your work, then you're like, did I write a positive or a negative first? What is it? Okay, so that's why I kind of stopped doing it, but I don't care. So minus, you're going to subtract all of these terms, okay? So if you're gonna do that, change the signs and use a different color. So instead, we're gonna add the opposite. So this becomes negative, which 0 doesn't matter, and this would become positive. So if you like to add the opposite, usually students are better at adding integers than subtracting. Because the subtracting is messy, because it's like 0 minus negative 8x, and that's where it's tricky. But I don't care what you do, so I don't want to confuse you, but have a one that works better for you. So this one becomes 0, which it should always become 0 or something's wrong. So this is a -1, and a 0 is -1x squared. And then I've got 0 plus 8x would be 8x. Or if it was 0 minus -8x would be a positive 8x. Okay, then I bring down the next term, which is a +1, and I start it all over again. So however many terms are in your divisor, are in the divisor, you have to have that many terms underneath when you go second round again. So then we just start back at the top, and we divide. We divide first term here underneath by first term here. So I'm doing -1x squared divided by x squared, which is -1. So I put -1. And then I distribute the -1 to all terms in the divisor, which is basically just taking the opposite. And then I line them right up below their like term. -1 times x squared, -1 times 0x, -1 times -4, oops, +4. And then we subtract all of those from the like terms that are lined up, which is nice. How many people like to add the opposite? Some of you like that? If not, how about you do your method and see what you come up with, and then we'll compare. Either add the opposite or subtract, whatever you like better.
Once you figure it out.
Oopsie, I think I forgot my 8x, didn't I? I must have. So this would be what, 8x minus 3? Yeah, I think I forgot that on there. I was going through this earlier, looking for mistakes. Okay. Now, how do I know I'm done? When the degree here is less than the degree here. Yep. So our remainder isn't always a number, right? Our remainder is a binomial or this polynomial. But when the degree is smaller under here, you're done. Okay? So that's my remainder, but to find the slant asymptote, I don't ever care about the remainder, except there is one situation where I care about the remainder to determine if it crosses its slant asymptote. But otherwise, for the actual slant asymptote equation, or oblique asymptote, all you need is the quotient. So this is your mx plus b. What's wrong?
I hope I'm following the line correctly, but
Did
should
I
it
mess
be
up?
8x plus 5?
Well, it's 1 plus -4, or 1 minus 4.
Oh,
Should be -3, I think. Did anybody else get that?
I got -3.
Okay. Do you see how so that's where the negative thing is weird. So did you do add the opposite, or did you do subtract?
I was subtracting.
Okay, so pretend like that's not there. That's why I never did the add the opposite. I stopped doing it because, so this is a minus, and this was a plus, correct? So it's 1 minus 4.
Oh, okay. Yeah, that makes
Tricky,
sense now.
tricky, yeah. Tricksy. Okay, so your slant asymptote is a line in the form y equals mx plus b. So you get the mx plus b from the quotient. So it's 2x minus 1. Okay? That's the line. And a graph can cross its slant asymptote. Okay? But what that dictates, we'll do a graph in a minute, is what happens far to the ends. Okay, so it gets close to that line, at far to the left and far to the right. Okay, yeah.
So I know like in the pre-work thing, it was you do the remainder over the
Oh, that
divisor,
was,
whatever, but then it says like, don't worry about that for the slant asymptote. Is
Correct.
that like every time, just like, don't worry about it for the slant asymptote?
correct,
as long
yeah.
as the
So that's
division-
when, I could show you something, and if we, maybe I'll do it on, we could do it on the next one, I could show you something about that. But yeah, in the video, you were just learning how to do long division, right? I don't know, maybe they were talking about slant
I
asymptotes.
think it was just like long
Okay,
division.
but in long division, that's how you could write it, right? The quotient plus the remainder over the divisor in an equivalent form. I'll show you that in the next
Okay.
one. Okay, yeah, good question. Okay, questions? So if I wanted to know, if just an FYI, I actually learned this from a student, okay? So remember when we tried to decide if a graph crosses its horizontal asymptote, and you had to set the function equal to the horizontal asymptote? Which you could do that with the slant asymptote, but it's really messy algebra. And the idea is, and I could show you on the next one if you want, to decide if a graph crosses its slant asymptote, all you have to do is set the remainder equal to 0. And if there is an x value, that's where it crosses. Okay, so just for fun, we could just write it here real quick. Does graph cross the slant asymptote? So you can, and this only works for the slant, not the horizontal. But it's the idea is that does the remainder equal 0? Okay, that's the quick way. Trust me, it's way easier than the algebra way. You get to the same place, but you don't have to mess with all that algebra. So we could try, is 8x minus 3 ever going to be equal to 0? It is, right? 8x equals 3, so x equals 3/8. So that's where it would cross on our graph. Okay, if we're going to do the graph. Okay, just for fun. I wanted to show you a faster way. I don't know if it says that on the steps. I can't remember.
It does for like the problem things in the page that lays it all out. Everything.
It does?
Yeah.
Oh, okay, cool. Okay. All right, because that's a quicker way. All right, anyway. Oh, okay. So, do you want to try? You want to do this one real quick? We might need to just do our next graph. How do you feel about it?
Good.
We'll do the next one. How about that? I'll let you do this long division one, okay? But you can do that other one for practice if you want. So let's get to here so we can actually do the graphing, okay? Because that's really the important stuff. All right, now, we're still going with the same rules, the same steps, okay? So if I want to graph this rational function, what does step 1 say to do? We're supposed to find the domain. So what do we look for on this rational function if we want the domain?
The denominator equal to 0.
Denominator equal to 0. It can't factor, I mean, we don't factor it. So what's going to make x minus 2 equal to 0? 2, right? So x cannot be 2, correct? That means I have a discontinuity at 2. Okay? So that means my domain is everything less than 2 or everything greater than 2. Okay? So at 2, I either have a vertical asymptote or a hole in the graph. One or the other. That's always the situation of whatever makes the denominator 0. Okay? So now I go, can I factor the top? Can I factor x squared minus 3? not with rational numbers, right? It would have to be with irrational numbers, and we don't do that, right? Because 3 is not a perfect square, okay? So it's not factorable, so that means that there is no common factor, which means there is no hole in the graph, okay? Because that occurs at common factors. Okay? So that tells me then at x equals 2, what have I got? A vertical asymptote, x equals 2. Whatever makes the denominator 0, when it's simplified, no common factor, results in a vertical asymptote. Okay? All right. So now what do? Horizontal or slant asymptote? Compare the degrees of the top to the bottom. Do I have a horizontal asymptote? No. Why?
Because the degree on the top is higher.
Degree of the top is bigger. The degree of the top is bigger. No horizontal. Only when it's smaller or equal. Okay? So no horizontal. Do I have a slant asymptote?
Yes.
Why?
The degree of the top is 1 more than the degree of the bottom.
It's bigger by 1. Slant asymptote. Okay? So find it. How do we find it? We divide. So I'm going to let you do the long division for practice. Alrighty? So you're going to take the polynomial on top and divide by the polynomial on bottom. Don't forget, you need placeholders for any missing terms. Sorry, I'm a little space challenged here. What is it? Whoa. So what's our slant asymptote going to be?
Y equals x plus 2.
Y equals x plus 2. And you should have gotten a remainder of 1. So the remainder is important if you're using it to decide if it crosses. Because some people are like, who cares if the remainder is wrong if the rest is right? Well, that's okay unless you need it for something. Jordan.
I'm confused about how you got the remainder, because I thought it was negative 2x minus 30. So then,
Because I subtracted. I did 0 minus negative 2,
okay.
which is positive 2.
That makes sense.
So if you like add the opposite, I didn't do it this time because I didn't want to mix anybody up, but you got to find your own way. Okay. Okay, so here we can check. Does our graph cross our slant asymptote? The hard way, or the long way, would be to set the function equal to y equals x plus 2 and solve. It's not hard, it's just more work, right? I'm just gonna write it down for notes, but you don't have to do it. So you could do this. Does it equal x plus 2? Or you can do the short way, is the remainder will set the remainder equal to 0. Is 1 ever going to equal 0? No. So does it cross? Yeah, does not cross. It's so much better. Oh yeah, I didn't do it. I didn't show you this. I'll show it to you next on Wednesday. What I was talking about. It doesn't work good in this one. Okay. All right, so we know it's not going to cross. That's good. Okay, so now we need our intercepts. How do you find the x-intercepts? What do you do?
Set the numerator equal to 0.
Numerator equal to 0. That's the fast way. Yeah. So what's my numerator? X squared minus 3. And solve that quadratic equation. How many solutions should you have to that quadratic equation?
2.
2. Every quadratic equation has 2 solutions. They might be the same, repeated. Okay, so I'm going to use this guy, this square root property. So plus or minus square root of 3. So that means I have we like them as ordered pairs. So I have square root of 3, 0, and negative square root of 3, 0. I guess I would put those on, start putting stuff on here. So I'd have to get a decimal approximation just to decide which 2 integers it's between. All right, and then find the y-intercept. The y-intercept is when x is 0. So f of 0. 0 squared minus 3 over 0 minus 2. Basically, it's the ratio of the constant terms. So it becomes 3/2. So the y-intercept is the point 0, 3/2, or 0, 1.5, or 1.5. Okay. And then it's like a puzzle. We put the pieces together. Okay. All right. So what do we have? We have a vertical asymptote at 2. Okay, remember, a graph will never cross its vertical asymptote. That means I'm going to have a curve to the left and a curve to the right. Okay, that's x equals 2. Let's put on the points first. So this is approximately 1.7 square root of 3. So we've got negative 1.7 and we've got positive 1.7 for x-intercepts. And 3/2 is 1.5 for a y-intercept. Okay, we could put the slant asymptote on first. It doesn't matter what order you go. Okay, so we know how to graph the line y equals x plus 2. You know how to graph a line? Slope-intercept form. To me that's a quickie, right? So 2 is the y-intercept, so it's right above there. That's a point on my slant asymptote. And the slope is, it's a number. It's the number in front of x. Yeah, it's 1 over 1. Slope is 1 over 1, rise over run. Okay, so that means we go up 1, right 1, up 1, right 1, slope of 1. Down 1, left 1, down 1, left 1. You want to check intercepts maybe for additional points? There it is. I was going to use my line tool, but sometimes that's not great. Extend it all the way across. You want it fairly accurate. Otherwise, there's to help decide if your points are above or below. You could always use the little equation to decide that. Okay? All right, so here's the cool thing. We know our graph doesn't cross either one of those lines, the red or the green. That's helpful, right? Okay, so here's the behavior at a slant asymptote. It either approaches from the top or from the bottom. What do you think it is? The bottom, right? It's not going to cross. If it crossed, we could, take that into consideration. So yeah, it's got to be the bottom. So it's got to come up and hit these points. And then remember at the vertical asymptote, it's either going down or it's going up. Which one do you think it is? Down or up? Down, because it's never going to cross the green line in this graph. It can, but not this one. That's what's beautiful about finding out if it crosses. So it goes down that way. There you go. Now, when you get to calculus, you'll actually know where that turn is. We just put that random turn there, but it may not be there. That's what you do with calculus. You find the highs and the low points. Dan?
So, excuse me, on
Yeah.
the exam,
So it's,
is graphing just 3 points acceptable, for representing?
oh, well, yeah, it's not like there's an exact number of points, but for this curve, yeah. Because we know where it is. It depends, like, you may only need 1 point to just decide if it's above or below something. So, if you need, sometimes you may need extra points, the intercepts won't be enough for you. So there's not like a rhyme or reason to it. It's kind of whatever in the situation, if that
So,
makes sense.
I
But for
guess-
that curve, 3 is fine.
Well, and I guess to clarify my question,
Yeah.
can the lines be kind of wobbly, as they're going near the asymptotes?
Yeah, I mean, this, the best you can,
Okay.
yeah. Just as long as it kind of looks like it's approaching. I know that looks sad because it's kind of going to the left, but sometimes when they're so steep like that, it's hard to draw them. So, yeah, we're just happy if you're in the ballpark, right, and you're approaching the asymptotes, and you've got your graph above and below the axis and stuff correctly. So yeah, if it looks like that, it's fine. You know what I mean?
Yeah.
Even if we didn't have all those points and we had to make a turn, it doesn't matter. Just make it turn because we don't know.
Okay.
Yeah. Okay, so now we got to jump to the other side. Now, here's the deal. I don't have 1 point over here. So if you don't feel comfortable deciding what to do, what should you do? Find a point. Plug in 3, plug in 4, plug in 5, plug in 6. I don't care. I would just do 3. So, because what are our choices here? Do you know what our choices even are? This would be a choice, like that, or this would be a choice, basically, because it's not going to cross the green, the slant asymptote. So what do you think it is? Do you think it's this curve on top or this curve on bottom? Or do you not know? I mean, you're new to this maybe, so it's okay if you don't know. The one on top? Why not the one on bottom then? There's a reason that we know that tells us it's the top.
There's no x-intercept.
It looks better, yeah.
It's not as symmetrical.
This isn't a fashion show.
Plug it in.
What is that point there? It's an x-intercept. Is there an x-intercept out there? Absolutely not. So that's how I know it doesn't cross there. Okay? But you're not maybe used to these. I've done this a few years. And so sometimes I have an idea and sometimes I have no clue if I've never seen the graph. So that's where, pick something on that side and plug it in. So I maybe plug in 3. Sometimes if you go too far out, they're really high, but at least then you know where the curve is. So if I plug in 3, I get 6. I got 6 also. So that means if you wanted an exact point, I don't care about the exactness. To me, it's just where's the curve, above or below there. But if you feel like you want to put that in, so something like this. So if your curve isn't looked that exact shape, does not matter. As long as it's in that region, we're good. Okay? Does that make sense? Okay. So plug in a couple points to check, just to be safe. Questions? These are fun. Love it. Love them. Love graphing. You should love graphing too. It'll get you a long ways in a lot of calculus places. Okay. All right. follow the rules, is all I can say. Okay? I'm gonna let you go through a little bit here and see what you come up with. At least go through step 1 and 2. And see what you come up with, okay? And then if we need to regroup, we probably usually do, so. See what you think about this guy. Last one. I'm sorry?
Sorry.
Oh, sorry. Because it's a sum.
So is that just
We can only do a product or a standard product report.
so you next?
No, yeah, because it's technically a sum of two terms.
Okay. So like that would be the input.
Yep, yep. Exactly.
So like the trick thing that goes going through, and I'm like, I don't know how to go, and I'm like, oh, okay, it's actually
Yeah, it's
easy.
very weird, yeah.
Yeah.
That happens a lot in calculus, that's why I like, we do those especially, when you do continuity and stuff like that. I'm just gonna tell you, if you're doing long division, you shouldn't be. Or do the long division and see what happens. I mean, something happens, but if you might not know how to interpret. Oh, okay, good, okay, sorry. Okay, so this is your new function. Which is Oh, good, yeah, now move on and get that guy. Nice job.
Yeah, no, I'm sorry. You're right. No, it is.
This is your new function. Good deal. New and improved function.
Because I mean, remember how we is this information?
Yeah, yeah.
Okay, so I'm just following the same steps as before. Don't break the rules. They'll lead you astray. Okay, so I decided the domain by what's the makes the denominator 0 from the beginning. Then I factored the top. I have a common factor that completely divides out. So that tells me that I have a whole or a removable discontinuity. At x equals 1, I take my new simplified function and I use that from now on out. Okay? What is this function if I graphed it right now? It's a line. It's not even a rational function. So it isn't going to have a vertical asymptote because it's not a rational function. Okay? So that's the tricky part. It is a line, but it does have a hole in the graph. So this rational function, its graph is a line with a hole in it. Okay? So once I determine the common factor, I cancel it out. I plug in the x value where there's the hole. I get that. I plug it into the simplified, and now I go from here and I do everything else with that new function. So here, vertical asymptotes, whatever makes the denominator 0. Is there a denominator here?
No.
No, it's never going to be 0, is it? So there is no vertical asymptote. Because this is a line. Okay? Is there going to be a horizontal or slant asymptote on this thing? No, because there is no denominator. It's a line. So NA. Is it going to cross? NA. There isn't one, so it's never going to cross. Oh, but a line has an x-intercept and a y-intercept, though. I can find those. Okay? So how do we find the x-intercepts? If it was a rational function, we'd set the numerator equal to 0. X-intercepts of any function basically is set the function equal to 0. So you're just going to do that. So it's tricky, it's weird. It's weird. We're not used to it. But it happens a lot in calculus. So I get 3x equals -2. So x equals -2/3. So it crosses the x-axis at -2/3. It's a line. I can find the y-intercept just by looking, but I can plug 0 into the function like I always do to find a y-intercept. So it's 3 times 0 plus 2. Whoops, where did I go? Which is 2. So my y-intercept is the point 0, 2. So I just graph that line and I put the hole on the line at 1, 5. Okay, so it's going to be, what is the y-intercept, 2? And it has a slope of 3. That's what I do. I just do the slope. Y-intercept slope. And then there's a hole here. Make it kind of obvious. A little overly large, but it's good. There it is. Okay, so it happens that we have rational functions whose graphs are just lines, but there's that hole is because of that common factor. The denominator divides out, so we don't have a vertical asymptote. We don't have a rational function anymore, okay? So if I graph this and I graph this, the function, the line, they'd be exactly the same except one has a hole and one doesn't. Okay. Perfect timing. Questions? Okay. So yay. Oh, go ahead. Sorry, Cameron.
How did you find the rate? Isn't that
How did I find what?
isn't that the asymptote?
It doesn't have an asymptote. It is just a line. It seems like it's an asymptote, but it isn't because there is no rational function after I take out the common factor. It becomes just a line. So it seems weird, but. Okay, so no pre-work for Wednesday. Your job is to get caught up on your My Math Lab homework. Okay, yeah. So you've got day 23 is this stuff? Or no, it's the piecewise and the continuity. And you should start on this because we're done. So I think this is day 24. So day 23 and day 24. Work. While you got this little reprieve. Okay? Awesome. And I'll get I have the showcases graded except for I had some technical issues again. I was trying to finish them. So I have 2 more left and I'm gonna go post those this afternoon. Okay? Have a good Monday. We'll see you Wednesday if I don't see you sooner.